All right, as for our dilation and similarity notes, we're going to talk about dilations, our fourth and final transformation. Again, reiterating, just remind ourselves over and over again what pre-image is and image is. Your pre-image is the image before your transformation. Your pre-image and your image is after the transformation. New vocabulary word, your non-rigid. Your non-rigid, we talked about rigid is dealing with congruency, and your pre-image and image will be congruent. Now we're going to have non-rigid, meaning not, so they're not going to be congruent. They are not going to be the same shape and same size. Well, what are they going to be? Well, with dilation, you're going to produce a figure that is similar to the original figure. Okay? What similar means is you'll still have the same shape, but now the size is going to change. This is the only one out of the four transformations that changes size. So since it's going to change size, it's either going to be a reduction or an enlargement, bigger or smaller. Now, how do you know how much bigger or smaller? You're going to look at your scale factor. Your scale factor is represented with a lowercase k. You'll see that through the notes. This is telling you how much bigger or smaller it's going to be. In a reduction, the scale factor is less than 1. So in parentheses, we'll put k equals, k. We'll put a less than sign. K is less than 1. In an enlargement, we're getting bigger, so we're going to have to be bigger than 1, so your scale factor is more than 1. And we'll put k is greater than 1. So we talk about, does it preserve congruency or not? Well, because of that word non-rigid, we just learned it does not preserve congruency. All right? So the first thing we're going to do is our problem, our first problem here, example, is going to be going back to 8th grade review on your dilations. The two important things we need to start with and highlight so we can see is what our scale factor is. So we have a scale factor of 2. And about what we are dilating it, which is the origin. Okay? So with this, there are a couple different methods, but I'm going to show you the easiest one for me. And once we look at example 2, you can also use the method from example 2. But here, in my opinion, the easiest here, we're going to go ahead and find our coordinates. A, oops, I don't want to put parentheses. A is at -2, 4. I'm going to skip some room here. Show my work. B, sorry, it's not -2, 4, it's -2. I did this in one of my classes too. -2, 3 is where A is. B, we're at 3, 5. And C, we're at 4, 2. Those are the coordinates of our pre-image points. Okay? So what we're going to do is your scale factor is a multiplier. So we're going to take all of these numbers and simply just multiply it by that scale factor of 2. So what that's going to look like is here we have times 2 times 2. So -2 times 2 is a -4. 3 times 2 is a 6. So A prime will be at -4, 6. We'll plot these in a little bit. 5, B will do the same thing, times 2, because that's our scale factor. So we'll have a 6 and a 10. So B prime will be at 6, 10. Same thing for C. Multiply everything by that scale factor. 4 times 2 is 8. 2 times 2 is 4. C prime will be at 8, 4. Now, it's a really good idea to make sure that you are plotting these onto the graph. If you're given a graph, that way you can compare them. So I want you right now, I want you to pause the video. I want you to go and I want you to plot all 3 of these on the graph and connect them, making sure that we are labeling them with prime. Now that we have that done, we need to take a look. The first thing I want you guys to notice is your center, as we set up here, was at that origin. And I want you to notice that between A, B, and C and their primes, because we have an enlargement, we are greater than 1 on the scale factor, each one's prime is further from the center of dilation. If we have a scale factor that is less than 1, less than 1, it's going to be a reduction. They'll get closer to that center of dilation. Okay? We also need to take a look at, we have the exact same shaped triangle. It's just bigger. It's just a different size. If point A we had down here, and we have this really weird cattywonk triangle that just does not look right, then we know we messed up on some step and we need to go back and double check the work. Okay? So let's go to high school now and see what we do when we are no longer using the origin as the center of dilation. So when we were going, what we're doing is we're using the exact same pre-image. We're using the exact same scale factor of 2. But this time we are, here let's highlight scale factor of 2. But now we're using B as the center of dilation. So we're no longer going at the origin. So now your point should get, because we have an enlargement here, your point should be getting further away from point B. So with this, you cannot use the coordinates and multiply the coordinates like we did on example 1. This time, we cannot use our rule that you'll see you just multiply them by the scale factor. So now we need to use our rise over our run. Well, when you look at your rise over your run, you're going from your center of dilation, which would be B, and you're looking at your rise over run to get to the other points so that you can then multiply the rise over run. I'm going to start with B, because if you're going from B to B, because we're going to find the rise over run from B to A to find out what to do with A, find out the rise over run B to C, but if we're going from B to B, there is no rise over run. It's not a zero slope, because that would be a horizontal line. But we're looking at B and B prime are going to end up being the exact same point. So here we want to say, we'll let them know, does not move. Okay? This is only when the point of the center of dilation is on the pre-image. Okay? So now let's go ahead and take a look. We're going to be using our rise over run, the slope. But what we want to do is we're not always going, well, let's take a look. We're going to go from B to A. All right? So to find our rise over run for A, we're going to take a look at, okay, so first rise, which we're actually going to find out we're falling, 1, 2. So we have a negative 2 over, we move over 1, 2, 3, 4, 5. And we went left, so it's a negative 5. Do not simplify this to a 2/5. Usually we would if we're writing an equation, but you need to leave it right here where it is, okay? So now what we're doing is we're taking our scale factor, instead of multiplying the x and y coordinates, we're multiplying the rise and the run. So here we'll multiply both of these by 2, and we're going to come out with negative 2 times 2 is negative 4, negative 5 times 2 is going to be a negative 10. Do not simplify it. We're going to wind it back over here. This is now what you're going to use to get to A prime. Start at your center of dilation, point B, and we'll do our rise negative 4, which means down 4, 1, 2, 3, 4. And then we can run, which it is a negative, so we need to go left, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's A prime. Now, there is another way that you can do this, and without the multiply, but you can only do it, the easiest way to do it is if you have a scale factor that is a whole number, not a decimal. You can apply your rise over run how many ever times your scale factor is. Here, this is 2. So I can go down 2, left 5, down 2, left 5. Twice, because scale factor 2. If it was a 3, I'd go down 2, left 5, 1, down 2, left 5, 2, down 2, left 5, 3. So, but that's, the best way that works with is only whenever you got that whole number. Okay, so that's why I want to make sure that we're practicing this way. Next, let's take a look at C. So we need to find out where C prime is going to be. So here we're looking at C. I find out I'm going down 1, 2, 3, so I have a negative 3, over, I'm only moving to the right once, so I'm going to the right now, so it is a positive 1. We'll take both of these, multiply them by 2, and we're going to come out with negative 3 times 2 is a negative 6, 1 times 2 is a 2. So back over here, we go down 1, 2, 3, 4, 5, 6, and then right 2 because it's a positive, 1, 2. And here is C prime. And what you'll notice is A prime and C prime, since it's an enlargement, got further away from B and B prime. Now when you trace, when that point is on the pre-image, When you go from B or B prime down to A prime, you're going to find yourself going straight through point A. Okay, that's how that works. Same thing over here, B prime to C prime, you're going to go straight through point C. And then we'll close it out and we have our triangle. And when the point, the center of dilation is on the pre-image, you're going to see one of the two images cozied up in the corner where that point is. Okay? So now I want you to read your coordinates. A prime, well, B prime, we already said it does not move, so B prime is just going to stay at that 3, 5. Okay? So go ahead and read your coordinates, and then these are the coordinates that you should have gotten whenever you read them. Okay? So let's take a look at what happens when we don't have a graph. Well, you can ask for graph paper, obviously, but in this case right here, we can just, generally what is going to happen, not all the time, but we've got these 3 points, we have our scale factor of 2/3, but we're going to be using our origin. So we can just do exactly what we did because it's the origin. Most of the time, it's when you only given the points, we're going about the origin. So we're going to do exactly like we did on number 1 here, where we multiplied all of our coordinates. Okay? So I'm going to take A, copy it down. We were told it was 0, 3. I'm going to take B, which we found it was 3, 6. And we're going to take C, which was 6, 0. We're going to multiply these all by the scale factor of that 2/3. So here we have times 2/3 and times 2/3 to figure out what A prime is. Well, 0 times anything is going to be 0. 3 times 2/3, you need to make sure you're practicing using your calculator with your fractions. This is going to end up being 2. So over here we move over to B, multiply both by that 2/3 scale factor. B prime, 3 times 2/3. Well, we already did the calculation over here, so why calculate it again? 2. 6 times 2/3. Well, it doubled, so we're going to double here. It's going to be 4. And then do the same thing for C and C prime. Multiply by 2. Now with this one, we got lucky. We already have the 6 times 2/3 over here, being 4. And of course, 0 times anything is going to be 0. And you're done. I didn't ask you to graph it, so you're all done. If I only want 1, only do the 1. Okay? So let's talk about how to find your scale factor now. We're going to actually start in high school right now and look at the not about the origin. The first thing we do here is make sure that we see the primes are not marked, but A is over here on the left, so A prime will be right here. C is at the top, so here's C prime. B is over here on the right, so here's B prime. Going from triangle ABC to the image, pre-image to image, our ABCs to our ABC primes, we're going to notice we should be seeing that we're getting bigger, so we have an enlargement. The center of dilation, okay, it's not the origin. If you look closely on your picture, you're going to see center right here. This is the point that is the center of dilation. So here we're going to find out, and luckily they gave us numbers on here so we could figure out, okay, it's -4 on the X, -9 on the Y. So this will be -4, -9. So we need to figure out, you can use either the rise or the run to figure out your scale factor. But if you use a rise on 1 from the center dilation to A and the center dilation to A prime, you have to use the same one. Okay, you can't do rise for A and run for A prime. It does not work that way. You have to use the same one. Well, here we only have a rise. We don't have a run. Okay, I usually just use the rise on all of them. But here, that's the distance from center to point A. From center to point A, 1, 2, 3. Okay. The center to point A prime we see is 1, 2, 3, 4, 5, 6. When you're looking at your scale factor, the ratio, okay, ratio in fraction form, we're looking at new over old always. If you're to paint a wall, you're going to put a new coat of paint over an old coat of paint. So you have your prime over your original pre-image. So here we want A prime, which was the 6, and we want the over A, which is the 3. And this does simplify down to your scale factor being 2. And we can check, did we accidentally switch these 2 around? Well, if we did, we'd have 1/2. We're like, wait a minute, it's an enlargement. So why do I have 1/2? That's less than 1. So that's one way you can check that. Okay, here we have an enlargement. We do have a number greater than 1, so hopefully we did the math correctly. So when we don't have, or when we go back to 8th grade review, whenever we have coordinates here and we are using, this one we'll go ahead and write in, dilate about the origin. Pause it so you can get that written in, please. We remember that our scale factor is always going to be the ratio of new over old. Now instead of using your rise or your run, you get to choose your x coordinates or your y coordinates, either one. I usually take the easiest ones, obviously. Smallers, not negatives, stuff like that. But for this first one, A, I'm going to go ahead and take the negatives because I want you to see what happens here. All right? So here, my scale factor, remember our new, the prime, y prime over the original or old y, we're going to wind up with the -2 over the -4. We need to realize here that we have two negatives. A negative and a negative are going to make a positive. Okay? So then the 2/4 is going to simplify down to a positive 1/2. One thing we do need to note down here is something that's extremely important to help us is your scale factor is never negative. Scale factor is never, ever, ever negative. Very important. So if you wind up with a negative for a scale factor, we made a whoopsie-daisy somewhere. Okay, so we're never negative. Pause it, make sure you have that written down. For B, I'm going to take M and M prime. I'm going to go ahead and use the smaller two numbers, the 6 and the 2, my y coordinates. I also want to use the y coordinates so you have an example so you can see it doesn't matter if you use the x's or the y's. Just you have to stay consistent. Can't say x from one and y from the other. Cannot do that. All right? So here, your scale factor, we have our new, which is the prime, over our old. Okay? And so we're going to have the 2 over the 6. Nice simplification here. Reduces down to the scale factor of 1/3. So there are your dilation notes.